I wanted to go over a topic that was a little bit challenging for me, total harmonic distortion. Now, I'm not going to go into the semantics of the topic because I'm assuming you already have a familiarity with it. So as we know, we have the total harmonic distortion. THD is equal to the square root of the sum of all the harmonics, not including the fundamental harmonic, over the fundamental harmonic. Then we have the individual harmonic distortion. Now this is the ratio of the individual harmonic over the fundamental harmonic. In the total harmonic distortion, we have the square root of the sum of all the individual harmonics squared, whereas in the individual harmonic distortion, we're only focusing on one harmonic each over the fundamental harmonic. As you may recall, if the THD is greater than 10%, then the system is polluted. Whereas if the individual harmonic is greater than 5%, then the individual is polluted. So what that means is if the individual is greater than 5%, we know that that individual harmonic is a cause for or a part of the total harmonic distortion. Let's do a quick example. So I'm going to show a couple of harmonics with arbitrary values alongside the fundamental harmonic. So on the x-axis we have the harmonics, and on the y-axis we have the magnitude. So the first harmonic is always the fundamental harmonic. Harmonics 2, 3, 4, n all the way down, those are the harmonic distortion. So we're going to make a table of odd harmonics, 1, 3, 5, 7. We're just going to add some arbitrary values for the magnitudes. So we have the magnitudes and we have the harmonic. So first we're going to solve for the individual harmonic distortion. So the harmonic distortion for harmonic 3 is going to be 22.02 over the fundamental harmonic 215.9. That's going to give us 0.1019, which is equal to 10.2% for harmonic 3. Harmonic 5 is going to be 12.18 over 215.9, which is going to equal 0.0564 or 5.64%. Solving for harmonic 7, we have 5.01 over 215.9, which is going to give us 0.0232 or 2.32%. So what this does is actually tells us which individual harmonic is polluting the entire system. So we can see that harmonic 3 and 5 are over 5% and contributing to the total harmonic distortion. So let's solve for total harmonic distortion and actually see what our percentages are. So again, total harmonic distortion is equal to the square root of the sum of all the individual harmonics squared over the fundamental harmonic. So we have the square root of 2.02 squared plus 12.18 squared plus 5.01 squared over 215.9. So the total harmonic distortion is equal to 0.1188 or 11.88%. Now we can see that that is over 10%, so this is a polluted system. So not only do we know that this is a polluted system, we also know what the contributing harmonics are that are actually contributing to the total harmonic pollution. I hope this helped. Keep moving forward. You got this.